Greetings and welcome, friends. Mr. Waddy here. We are taking a look at the homework from 5.1, solving systems of equations uh, by graphing. And we're going to, at least in this course, look at three different means of solving the same type of problem. They each have their different strengths and weaknesses. To be honest, graphing isn't my favorite, but that's okay. It still is a means for us to kind of visually understand what's going on. And this is basically the idea. So a system is when you have more than one equation and more than one variable. So notice here I've got two unknowns, right? X's and Y's, and I've got two clues that are going to help me solve for those X's and Y's. Now, each of these equations is a line of which there are infinitely many points on them, right? But there will only be one point that both of those lines share. And so question 5 here is saying, tell whether the ordered pair is a solution of the system of linear equations. And so here's an ordered pair. Here's a particular XY combination. And I'm going to do a check to see if it works in the first line. So I'm going to plug in 3 for Y. I'm going to plug in, let's see, -1 for X. And I'm just going to PEMDAS this. So I'm not allowed to use any algebra. I'm just doing order of operations. -7 times -1 is +7. And, 7 minus 4 is 3. Cha-ching. It worked. It worked in the first equation. But that doesn't mean it's the solution. Like I already said, there are infinitely many points on a line, so I could have found one of those infinitely many, and it might not work on the next line. So let's try out the next equation. So for y and x, I'm going to plug in the 3 and the -1. So 3 equals question mark. I'm wondering whether or not it's equal. 8 times -1 plus 5. So is 3 equal to -8 plus 5? 3 equals negative. Oh no. Oh dear. It's not equal to that. That means that -1 comma 3 is not a solution of the system. All right. So beware that just because you found something that works for one of our equations does not necessarily mean it will work for the other. So here's like what we end up doing is we have some problems that kind of like piecemeal give us these solving by graphing steps. All right. So we know how to check solutions. Now they're asking us to use the graph to solve the system. All right. Now, here are two equations. I happen to pick the one where they gave us equations that were not in slope-intercept form. Slope-intercept form being, of course, our friend y equals mx plus b. So if I had to graph these on my own, I probably would have converted these to y equals mx plus b. I would have subtracted 3x from both sides, divided both sides by 6. I would have added x to both sides and then divided both sides by 4. But they already graphed them for us, so maybe I don't have to bother. But the solution of the system graphically, the XY combination that would make these equations true simultaneously, is going to be the point that these two lines intersect at. So what is that point? What are the coordinates of that point if I wrote them as an ordered pair? Let's see. In terms of x, it looks like -1, -2, -3, -4, right? And in terms of y, how high is this point? How high is the y? Anybody? 5. Thank you, thank you. So -4, 5, I suspect is the solution. And then I would do a check, and I'm going to do this check even quicker than I did the last one. Be careful, they put the y before the x in this equation. So let's see, 6 times 5 plus 3 times -4. Yeah, I don't think I'll take the time to do the checks for the other ones, just so we can do more examples and get today's lesson. So let's see, 18 equals 18. It works in the first equation. Cha-ching. Let's check it in the second equation. So the opposite of x, so that's the opposite of -4, plus 4y, so 4 times 5. Is that equal to 20? Oh, 24. There we go. Not 25. So that's +4 plus 20. Oh, Got a feeling this is going to work. It works! So therefore, since this is true, it worked in both equations, and therefore this is, in fact, the solution of the system. Now, in terms of graphing, right, it works. Like visually, I'm just looking for the point where the two lines cross, and that point will hopefully work in both of those lines. It works as a method. The weaknesses of graphing was, what if my solution was like 1,224, comma, a billion and three, right? Like I'd have to draw a grid and draw those graphs, and like the intersection would be so far away from the origin, it would be like a pain to do. Or so graphing only kind of works at like close domain and range to the origin effectively. Or what if my solution happened to be at like 0.127, comma, negative 0.00034? I'm not going to be able to like graph that point very well or find that intersection. So graphing is not very accurate. So some of our solutions on this homework were estimates, where we were just getting it close. And as a result, when we would have done the checks, they would have been close to one another. So graphing is great for kind of like visually understanding these problems, but they are not. It's not the most accurate method. It's not the most effective method all the time. All right, so here we go. Solve by graphing. Conveniently, these are in slope-intercept form. The slope of this first line is 1/3. The y-intercept is 2. Right. Hopefully, you guys are becoming masters of slope-intercept form. So I'd go up 2 for the beginning, and watch me move by my slope. Watch me move by my slope. Let's see. That was just like to the tune of the cell phone commercial for the Juke that came out probably like 15 years ago, where people were dancing because their phone could move. They'd say, "Watch me move like my Juke." But anyways, let's see. So here's our first equation. I'll make this the light blue equation. I gave you guys the grid. I don't know where these lines are going to cross. And that's actually another challenge. Like I said, what if I got all of this work done? I graphed both of these lines, and then they ended up crossing over at like 100 on the x-axis. I'd be like, I don't know. I'm kind of stuck. Let's see. So m equals 2/3 for this line. The intercept is 5. Oh dear. All right. Let's see. Up 1, 2, 3, 4, 5. Okay, hopefully the intersection is going to occur. I think it might. Up 2 and over 3, right? So up 2 over 3, up over 3, and I could plot more points. It looks like the lines they're getting further away from each other over here. So I'm hoping there's an intersection down this way. And a slope of 2/3, I do want to point out, is the same as a slope of -2 over -3. So I can technically go down to backwards 3. Down to backwards 3, down to and backwards 3. It looks like I could have found the intersection that way if I wanted. So let's graph this line in the lovely purple. Let's see. Let's see. I'll just use the points that I would have started with. Wouldn't have necessarily traced it all the way back there. So even like my line shifted a little bit, my intersection actually wouldn't have been exactly right. So it's kind of graphing's not the most accurate, even when I do it all right. So there's my two lines. My intersection is my solution. So the question is, where is that point? That point appears to be at, this is the -10, by the way. So it looks like it's -9 units on the x, and it's down 1, -9, -1. Looks like our solution. All right, so that's the idea to solve a system, right? I had two clues being the equations, and I had two unknowns being the x and the y. And I found the combination of x and y that make those equations true, right? So you could also actually think of these solutions as x equals -9 and y equals negative. Right? So let's what was the candle problem? Candle like a candle in the wind. All right, here we go. let's write variables. It says you sell. I thought I mentally combined those words. I was going to say you smell large candles, but no, that's not what it says. Although it might be true. You sell small and large candles at a craft fair. Wow, guys, I'm there. Like, imagine this. What would I name my candles? Waddy candle? No, I don't know. I'll have to think of something better. You collect $144. Yes! Whoa! $144. Selling a total of 28 candles. All right, here's the question. How many of each type of candle did you sell? How many of each type of candle? So there are two types of candles. Oh, they also, notice this. This is a classic thing. Some of the clues were in the picture. Notice there were no words that told me that the big candles are $6 each and the small candles purple. All right, so sometimes some of the clues that your textbook gives you will be in the picture. So each type, how many of each type? My variables are often the thing that the question is asking. And here it's asking me two things. How many of each type of candle did I sell? So let's say X is the number of small candles sold. All right, that makes sense. So that's not a dollar amount, that's a number amount. And let's let Y equal the number of large candles sold. All right, and now I'm going to try to write some equations that represent this. These equations are based off of the clues that they gave me. All right, so it said, I'm going to start with this clue first. Yeah, you sell a total of 28 candles. What's an equation that would relate the X's, the Y's, and the 28? How do you think I could relate those things? Right, this is kind of a new-ish skill, so I realize it might be tricky. So let's see, the total number of candles was 28. Where could I get the total number of candles? What things could I add together to get the total number of candles sold? Well, I sold some small ones and I sold some large ones. So if I add the number of small ones to the large ones, that should equal the total number of candles sold. You guys agree? Right. So this equation is regarding kind of the number of candles sold. The next equation I write is going to relate to the amount of money I made. So I'm going to say $144, all right, is equal to, well, how much money did I make for each of these candles? For every X of the small candles sold, how much money was I making for those? I was making $4. So $4 for each, the price per small candle, multiplied by the number of small candles. This product will represent the amount of money I earned, or my income, my revenue, right, from the small candles. If I take the number of large candles and multiply by the price per large candle, this number would represent the amount of money I earned selling just a large candle. And if I add those two dollar amounts together, that should equal the total amount of money that I earned. All right, so there's my two equations. Now I'm going to solve this graphically. All right, I actually really wish I could solve this using today's, but we'll use graphing. It's just fine. Let's I don't know, put these in slope-intercept form. Let's see. So X, I'll put the other one in slope-intercept form first. My bad. Sorry if I decided. So let's solve for Y. Subtract 4x from both sides. Right, 6y equals negative 4x plus 144. Now what could I do to get y by itself? Mis amigos? Y is being multiplied by 6. What's the inverse operation? Yeah, divide by 6. And everybody gets divided by 6. Everybody. Y equals negative 4 over 6. That reduces to negative 2/3 x. So there's my slope. And 144 divided by 6, what's that going to be? Is that 24? Yeah. All right, so there's one equation. Yeah. I love it. Impeccable logic. That's actually exactly what I did in my head as well. I like your thinking. Not just because it's my thinking, but that is a really good strategy. So let's see. The other equation was x plus y equals 28. How could I put this in slope-intercept form? How could I get y by itself? Yeah, subtract x from both sides, and I'll get y equals negative x plus 28. So here's my equations. Both of them have negative slopes. Man, I'm thinking I've got to, let's see, count by fives, count by fours. Ah, man, this is going to be an ugly, ugly problem. Try to graph. My grid isn't going to be big enough. I got to go at least as high as 28 because that's this y-intercept, right? Yeah. So let's. What do you guys think? Let's see. 2, 4, 6, 8, 10. I think I need to count by threes. Yeah. I'll count by threes. So 3, 6, 9, 12. Yeah. I'll label all of them in this case. And let's do the same thing for the other axis. So my y-axis is measuring number of large candles sold, right? And the x-axis is the number of small candles sold. And we'll also count by threes. 3, 6, 9, 12, 15, this one, 18, 21, boy, 24, 27, 30, 33. I'm just labeling every other one for sake of time. All right, so let's graph this. All right, y-intercept at 24. Got 'em. All right, the slope is down 2 over 3. So there are 3 units. This is what's tough. There are 3 units in between these. So I'm going to go 2/3 of the way down and over 3 units, which is a full box in this case. Let's plot a few of these just to try to help ourselves out. So right now I'm 22 units high. So let's go down 2 again. 22 minus 2 would be 20. Would be here and over 3. And so I'm at 22, going down 2 over 3. Down 2. 20 minus 2 is 18. Aha, so I land on a grid line again and over 3. Also notice that if I went down 2 boxes and over 3, I actually would have landed at that point. Only because my scales were the same in both directions. All right. If I was counting by ones on the x-axis and threes on the y, I couldn't do the down 2 over 3. So let's actually do that again for this next one. Down 2 boxes over 3 boxes. And the reason that works is because it's proportionally equivalent to down 2 and over 3. So let's draw this line right here. Best as I can. Right, and if you guys were like drawing on your own graph paper or something, like if you made your own grid, it would be so hard to read anything accurate off of it. It would be crazy. Let's see, the other one, y equals negative x plus 28. So y-intercept is at 28. That's like 2/3 of the way up. And the slope is -1. So I would go down 1 over 1. That's like a third of that box. Down 1 over 1. Down 1 over 1. And it would be tough. But another way I could figure this out is if I keep going down 1 over 1, since the y-intercept is at 28, it turns out that the x-intercept is also going to. But yeah, so it's tricky graphing. Did I say you could use the Desmos graph to run this problem? I don't remember. I might have. All right. So all of that work. Whew, yeah, we've been doing this problem for like a long time. All right, what is the intersection of these two? That looks like it's occurring at 12 and maybe 16, I'm guessing. All right, 12, 16, I think, is the answer. So that means my answer is you sold 12 small candles, remember, because that's what the X represented, and 16 large candles. And let me just open this up in Desmos super quick. Super quick. So let's see, what was my first equation? X plus y equals 28. Nice thing about Desmos is it can graph even without slope-intercept form. And 4x plus 6y equals 144. Let's do the zoom out. Oh, look at this. So I've got a similar graph, right? Similar graph, right? I think you agree. And I can actually find the intersection using this. If I click on a line, oh, I can find the x-intercept. I can click and drag on this line and kind of move along it. Notice that the intersection is actually gray. If I highlight over that intersection, it'll give me the solution. All right, so I was right, right? Even though like my lines weren't as perfectly drawn as that. But yeah, so 12 comma 16, I got the same solution. Right. Good times. So now we know how many of each candle we sold. And that's why it's important to have a good inventory. So then you don't have to do all of this math work to figure out how many of each candles you sold. Right. But we're going to learn better techniques today. It's going to be great. Have a great day, friends. Bye-bye.